I'm going to start my presentation with a meme. And this, Paul shared this about a month ago in one of our Slack channels, and I just thought it was great because this is my general feeling about a lot of the AI. It's cool, it can do all these things, and you look at actual user needs. It's just about like, why do I care? Like, it doesn't serve something that, that I care about, or may serve your organization, what you're showing as an example, but it doesn't serve mine. So I thought about what business problem do we at Harmonic have that is worth solving that AI can help solve? And a very present one is, how do we estimate accurately? We care about estimates because we want to be able to tell a customer, here's how much it's going to take to build this thing for you. Our customers care about estimates because they want to know how much it's going to take. And we also don't want to spend hours and hours and hours estimating and then give the customer a number and then them decide, it's actually more than we're willing to spend, we're going to go a different direction. Well, it would have been great if we could have found that out in a few minutes rather than spending hours doing that. There's also the emotional side of estimating, is you're sitting there looking at a list of tasks, and you can go one of two directions. You can go, well, if I estimate too high, then the other person is going to think I'm dumb and incompetent. Because gosh, why would it take you that long to do it? And so you want to be optimistic. You end up underestimating. Or you go, I don't even know. I'm so afraid of underestimating that I'm going to overestimate by so much that it's, you're overestimating by 6, 7, 8x, which is, again, not useful at all. I'm going to show the power use case that I've got here, and then walk back through how we got to this point where we're going to go next. What I have here is just a text file of tasks, of just essentially a to-do list for a project. I'm going to drop it into this container field and select some options, which I will explain as we go along. Click the button. And I should explain the reason we have Randy's computer here connected to my computer is we are not using OpenAI for any of this. We are using our own embedding server, and for the time being, this machine is our embedding server because we had an extra MacBook Pro lying around with an M1 Pro processor, so we said, hey, we already own it, why send our money to somebody else? So it's imported this task list, and it's going to put estimates into all of these tasks, and then we get a grand total. And that was taking roughly 30 seconds or so to rip through this whole long list to do that. So we started with asking the question, what data do we have? We've got 7 or 8 years of project management data. In our project management system, we've got lots of tasks that have titles and descriptions and a bunch of comments. And then we have, in our timekeeping and how we invoice, we have time that's booked against those individual tasks. So all of this estimating is based on our own internal data. So originally we took the combination of the title, description, and comments and created an embedding of just that, which is this ticket details option that I've added here. I said we put together a private embedding server, set up a sentence transformer that is capable of embedding that input into a vector, and then we just drop that vector into a container field. And so what this is going to do is I'm going to take that task and choose which of the 3 embeddings I want to use, and I'll get into what those other 2 are now. And I'm just going to say, hey, estimate that. And this is saying, hey, based on 100 similar tasks, I've set the limit to 100, we think this is going to take 28 hours. And what we did, that semantic find that you've seen previously, and then just did some super basic statistics on it. We just did an average, and then I showed like a min and a max and a standard deviation, right? And then, but where can we go from that? Now, before I jump into how we started refining this data, I do want to touch on how we set up our private embedding server, because we're not using OpenAI. Part of that's because we didn't want to pay for it, but also this is our data, and we don't want to be sending that out to the internet. So all of this has happened completely within network. It's never left our network, never left our office. First, we set up an embedding server using Ollama, which is just an open source AI embedding tool, and it didn't work. And the reason is twofold. The way FileMaker 24 has been coded by Claris is it works with OpenAI, and OpenAI's routes, the route pattern, and responses. And so it's expecting that specific format. So we can see the difference in the Ollama route, which is /API/embed, and the OpenAI route, which is /v1/embeddings. So because of that difference in route, as FileMaker was trying to make that API call through the script step that they give us, that was failing. The other thing is in the response. So Ollama's response is structured something like this. OpenAI's response is structured like this. And FileMaker is expecting the response to be structured like OpenAI's response. Randy just built some middleware to convert the route that FileMaker is going to call, which is the pattern from OpenAI, and transform that into the route that Ollama is expecting. And then that same middleware transforms the response that Ollama spits out into the structure of that OpenAI gives. And then it worked just fine. But what I just demoed was actually not using Ollama. What we did, Wim de Kort has a great article on how to go about setting up a custom embedding server. And as it turns out, FileMaker Server 24 ships with a Python file on server, and it's documented where on the server that gets installed. And so you can, the story goes, you can take this file as is, put it on a different server or on your FileMaker server if you want, and then you're just able to call it. And for the most part, everything that Wim said in that article worked for us, with one exception. And for those of you who are techie that care, I wanted to call out the one thing that we had to change. Maybe we were missing something, and this is why we had to change it, but right here. In the Python, I say we changed it, Randy changed it. He figured out what was happening and got this resolved. This line here, 287, that we're commenting out, was what was in the Python script that Claris gave us. We had to change that one line of code to this. And the difference in those two outputs was this. So this first line, if we look at the embedding object, the script was outputting np.float32, parenthesis, number, et cetera, et cetera. Once we changed that, our output was just a number. Anyway, for what it's worth, if you're trying to set up your own embedding server, we had to fiddle with some things to get it to work, but we got it to work and it was smooth sailing from there. The next thing, if you're going to build a better mousetrap, as my example is here, I don't know if 28 hours is actually the correct answer. So we started thinking of how do we make these answers that it's giving us more accurate. So Randy got the idea of let's take the task title, description, and comments and feed that to an AI, essentially chatbot, and ask it to summarize it for us. And then take that summary and embed that. So if I choose the second option, which is the embedding of the title, description, and comments, and the AI summary, so all four of those things, and I run that again, I still get 28 hours. Okay, it didn't change it all that much. If instead I switch to just comparing against the AI summary, it goes down to 23 hours. That's interesting. Which one of those is more accurate? I haven't determined yet. But so there's those different knobs that we can turn. Another knob that Jeremy was mentioning is the cosine similarity. If I constrain my results to similarities that are greater than or equal to 0.45. I chose 0.45 because in my testing I found with our data that generally produced something that was okay. hey, now that jumped down to 9 hours, which, depending on how better of a mousetrap you're going to build, that may be significantly more accurate. But you'll also notice that we're only comparing against 25 tasks now because it constrained what we found. Now, the next idea that we had was if we look at our min and our max here, so the minimum number of hours of these related issues was 1 hour. The maximum was 64 hours, which seems like a lot. Yeah. So I said, me as a human, knowing what I mean by build a better mousetrap, saying, no, it should not take more than 25 hours. Now, even 25 hours, that's a significant investment in a mousetrap. But, so this is just going to omit anything that is greater than 25 hours before it runs my averages. Now it drops down to 5 hours. It's omitting those things that are too big. You could also do it in the reverse, where, hey, what I mean by build a better mousetrap is we need to spend at least 30 hours on this. Anything less than 30 hours is just not worth thinking about. If I rerun that now, I've changed it to 60 hours because I'm omitting those things that I, as a human, know don't accept anything that's lower than this number. The next thing that I played with, along that same line of the estimation, was I wanted to exclude outliers, right? So if I've got a found set, so let me look here. The data that it's actually looking at right here is these records. And if I look at this spent time column, there's not really a good, okay, I'll do this one. Add a print button. I want to go back to that one. Okay. So the max it's saying is 501 hours for adding a print button, which, I don't know, seems excessive. Just a little bit.
But does it really?
So I can see in here that it has found, there's something in here, 207 hours that it's found something that it thinks is somehow similar. Okay. 501 hours for something that it thinks is similar. Clearly it's not similar. Or that's a very nice print button.
Lifetime upgrade.
Printer support included. That's probably why it's so high, right?
Plug Windows.
Yeah. I added this option to exclude outliers. And the scripting for that is really quite simple. An outlier is defined as something that is greater than or equal to 3 standard deviations above or below the mean. Once I get my found set here, I am going in and finding what is our standard deviation, and then just doing a find to omit things that are greater than 3x that away from the mean. And when I do that, that 20-something hours jumped down to 15, and now my max is 162 hours, which still seems like a lot for adding a print button, but significantly less. And I don't have to know what should my range be. I can just say, hey, exclude the outliers, period. Before I get into weighted average, because I nerded out a little bit on that one, part of this in getting good responses is to know your data. So the semantic search is just going to find similar things to whatever you pass into it. But it's up to you to decide, is this data point even worth considering in our data set? I added a number of things in here. For instance, so starting here, I said, hey, I only want to include things that are done. If we are still working on a task, then the amount of time that has been booked against it is useless for this case. It's going to skew the numbers. So I'm going to constrain to things that are marked as done or closed, and only find things that actually have time spent on them. If there is no time spent, that's also going to drastically throw off the numbers. I'm also here omitting records that have a resolution. So one of the columns in our project management is called resolution, and we have 2 data points that we've set up. One is called won't fix, and the other is duplicate. So if we or the customer has made the decision that, yeah, we put maybe some time on this, but we're just not going to do that for whatever reason, then I don't want to include that in my results. Also, if we've marked an issue as a duplicate of something else, I also don't want to include those numbers because they don't really count. And I, as a human, know that they don't count. I, as a human who knows my data, knows that they don't count, that I don't care about them for this purpose. Then there's some other things. I'm omitting these, so we have a series of 4 when we do go-lives for customers, and the title of the task is build 170, build 171, build 172. They have the word build in them. And so the semantic search goes, build, that's similar. And it includes those. And I just go, no, that is, we're not using build as a verb there. This is a noun. So I just said, yeah, just for those, because there are so many issues or so many tasks that have that title in our data, I just said, no, just omit those. Some other things like that. Knowing your data. The last thing that I did was I wanted to weight the average. If I look at my data set for adding a print button here, and I'm going to sort by our similarity. So I see there are some things that have a similarity of 0.46, so on and so forth, and other things that have a similarity of 0.63, right? The things that are more similar, I would like to have those averages weighted a lot more than things that are dissimilar. And so there's a standard equation to calculate a weighted average, just using the AI similarity as your weight, but that didn't get me the results I wanted to see because it wasn't weighting them enough. So the cosine similarity value that's returned is just linear. And by that, the distance between 0.45 and 0.46 is the same as the distance between 0.6 and 0.61. And for my weighting, I didn't want that relationship to be linear. I wanted that relationship to be exponential. So the more similar it is, the more it weights. And the less similar it is, the less it weights. So what I did is I created field, where is it? There's that. There is. There, okay, here it is. So I created a calc that takes that similarity and just transforms it into an exponential relation rather than a linear one. So this effectively is e to the power of 100 times that similarity. I'm going to change that to 1,000 because I think I liked that one better. But that started out as 5 times the similarity. And I went to 10 and played with numbers until I found something that felt right to me. And like Jeremy said, you've got to play with this, play with the different knobs to see what actually ends up getting you the best results. If I use a weighted average, now all of a sudden that jumped down to 6 hours. And then if I say increase the cosine similarity, it stays 6 hours. Okay, it's probably because of the weighting I was doing. But that use of the weighting really reduces the amount of time, and in our case here, hopefully makes it more accurate. I can see that the maximum here is still 64 hours, which seems ridiculous. I'm going to just omit anything that is greater than 30 hours. Okay, I still get 6 hours as the estimate. What if I say omit anything greater than 20 hours? Okay, that weighting is strong.
Treat it like you're actually doing it. How long do you think it would take to build a button?
Yeah, so that's the interesting thing here, is I actually think 6 hours might be reasonable because there's if by building that print button, you need to build a new layout that is printer friendly and then fight with all the little gotchas and stuff there and then pass it off to the customer to test, and then they go, I would like these 2 fields, and could you reorder these, and I would like this sort, and then that back and forth. By the end of that, you may actually be 6, 7, 8 hours in. that is entirely possible. The initial work may only be 2 hours or 1 hour. But then there's all the ping pong that happens back and forth. I'm going to try this one more time where the goal is, okay, let's try it with something smaller. So that's just a different file. Use the weighted average, sure, all that sounds wonderful. So what this is doing, there we go, boom. So it's saying for this task list that I just uploaded, it compared it against our historical data of what it took us, and it's saying, hey, for this whole set of things, on average, we think this is going to take 80 hours. I don't know if that's true. We're still fiddling with that. But a few caveats to this is it's all influenced by the quality of your data, right? If you're in your project management data, you have one task that you've put 800 hours against because it's just the whole project. That one data point is going to throw everything else off. Because when you put that much time into one thing, that estimate is basically worthless. Also, if you have lots of little tasks, say you've got something tasked out with 10 different tasks, and then you do all of that work against 2 of them, and you put no time against the others, that's also going to throw off your data. One of the things that we're going to try to get better at is better project management hygiene. So naming tasks better, being more diligent about adding comments to issues. Because if the only comment on the issue is, this is done, that's not all that helpful. This is done and you've plowed 70 hours into it. Okay. If it's fix the button and then this is done, that's not a lot of context for the AI to go off of. I think the one last thing I'll throw in is where we're going next. That was actually Randy's idea. We just didn't have time to implement it. Was implementing the chat with database feature into this. Like I'm manually doing in the scripting by omitting certain things from my find before I do that semantic search. Wouldn't it be nice to, oh, that's not what I wanted to do. Wouldn't it be nice if we could enter in the name of a task and then based off of that, chat with the database that would give us a SQL query to essentially find things that meet this classification, and then strip the where clause out of that SQL query and add that to our find request to further limit down the results dynamically before we even do that semantic find. So I'm hopeful about the potential value that could bring, and I'm hopeful about what this tool can do for us internally at Harmonic and the value that it can bring in the turnaround time to produce estimates for things, and then that allows us or the customer to decide, is it worth moving forward with this? The faster we can come to a decision, the better for everybody involved. Yeah.
I don't know if you thought of is you have all this data that has all these descriptions of things.
Mm-hmm.
Having the AI ask you, the LLM ask you questions, like you put in this task, and it can ask you, is this more like this, or is it more like this?
Mm-hmm.
And to narrow down that search as well.
Yeah, I think, Randy, you had some ideas around that. But for instance, if what we're doing is adding a print button in FileMaker versus adding a print button on a web page, that's 2 different sets of work. And typically, it's going to be a lot faster to do it in FileMaker than it is in something else. Which team at Harmonic is doing it? What tech stack is this work being done in? That can greatly affect the amount of time.